Okay, everyone, I shared the screen. I started recording the class. It is 6 p.m. I ask at least one time share your screen so that I can see you. Charity and Sami, Rose, please. So that if you can show your video, I can at least see you. Thank you, Sami. And if you need extra time, if you need extended office hour, email me. I can give you extended office hour extra time, okay? So today what we are going to cover, we are going to cover most important thing, data analysis and data mining. There will be altogether 80 problems. I'm going to cover 2 hours, 30 minutes, okay? Sometimes I will go by the speed of light, okay? Clear, right? Okay. And first problem last week that I gave, it is called the bonus point. So you can submit it anytime. Okay. I might open another bonus point assignment folder in the Western Online. Do you have any questions, comment? No, right? Okay. So after this, the next 7 or 6 homeworks, you are allowed to use either Python or R, one of the two. Many of you are familiar with the R. If you solve the problem by using R, that's fine. Okay. Let me start. So these are the packages, line 5 through line 8 that you are seeing. These are the packages. So some other people, they have developed these packages. We are going to use the terminology, the code, the syntax from those packages. Okay. And sometimes we have to use pd dot syntax, np dot syntax, sns dot syntax, os dot syntax. The line number 8 is telling you import os. Os means operating system. Okay. They develop something we are blindly using. Like the way Steve Jobs and Microsoft, they developed Windows operating system and touch phone, we are blindly using it, right? There are so many things people have developed. We are using this. We do not go to the deep on that. So similarly, these are the packages some other people develop. We are going to use these things. So I run these packages. What happened to you? Why are you not running? Let me see. Oh, I'm sorry. I'm very sorry. It is running. So let me run it. I was in. Here you go. Okay. So now os.get, that one, line number 12. Line number 12 is telling you operating system get, get CWD, current working directory. Understand? So directory means what? In a folder, you put all the data, all the code, everything. That is what known as the CWD. CWD on line number 12 is telling you operating system dot get current working directory. When I hit these things, I got my current working directory is download. Okay. Download is my current working directory. As download, that is my current working directory. So I have to copy these things. I just need to copy these things. User MC264, just download. I just want to change it here, downloads. DOW and downloads. And that's it, downloads. And what the line number 17 is telling you? Line number 17 is telling that you are setting up a working directory, OS change directory, CHDIR. Okay. So rest of the time, anything in the download folder, data or anything, I can easily bring it in there. Line number 17 is telling you how to change working directory. For example, you want to work from another folder from the desktop, then you copy that directory by going to the properties, right click and find that. You know how to find that, right? You know, right? Sami, you know? Sami, good. Okay, so now I change it in here, working directory. Now let's go and try to read the data. Yes, data is reading. Class practice underscore data, which is line number 22. I read the data. My data is D1. Okay. As a data analyst, as a data scientist, as a predictive modeler, as a statistical modeler, as a computer scientist, when you will start working on project, first of all, you will be given a data. Understand? So your task is to import the data either in Python or in R. Clear, right? So I have shown you how to import the data. I have data I saved in a folder, in a directory. I declare that directory as my working directory. And then when it is declared by line number 17, then what you are going to do, you need to import the data. Line number 22, I import the data. I name the data class practice data as a D1. D1 is the name of my data, okay? If you do not like my naming culture or naming thing, you can change it and put your boyfriend or girlfriend name, okay? If you like your spouse so much, you can put her name there, okay? So I like D1 means data 1, okay? So now let me go there. So data analysis, data mining, and basic statistics by Python. What I'm going to cover today, 2 hours, 30 minutes, I'm going to cover all of these 85 problems, okay? Clear? So these are so fundamental, so important thing. Whatever fundamental things would be in there, I put all of these things in this document, okay? And you get 1 week time to solve your homework. Your homework is here. Come on, homework. This is your homework. Download. This is your homework, okay? This homework has 40 problems, okay? Clear, right? This homework has a strict deadline, but if you still struggle, just take help from me. Clear, right? This homework is very important because that will give you the solid training on how to analyze the big data, as well as how to do single loop, double loop, how to write function, how to draw different types of graphs. Clear, right? So one piece of advice, read these document multiple times, 85 problems. Okay. And also last week, I gave another document, read those things. And after reading multiple times, read this homework problem multiple times. For example, suppose you read the question number 7, create a column of missing values corresponding to each row of the day2 data and name it as a missing. Try to find whether this type of problem I solved in the class practice document. Understand? Match. Understand? So, and then all the codes are in there. Wording is different. Okay. So after doing that, now come in here, import pandas, numpy, seaborn, and operating system libraries to the Python, which I already did. Question number 1 done. Get the current working directory of Python, which I already did. Get CWD, right? Get CWD and parenthesis, I got that. Get CWD, OS operating system, I got that. Question number 2 done. Question, how many variables? No, not this one. The question number 3, set up the own working directory, which I did. Then question number 4, read the class practice data to Python and denote it as a D1, which I did. Now question number 5 is asking you, check the number of observations and variable in the D1 data. D1 data, now you are asked to check the number of observation as well as here is the thing. If you run this, so there are 20,900 rows and 25 columns. Okay. What I did here, np.shape. np.shape. How do you write the same code in R? What is the R code for np.shape? If you want to check the number of rows and number of columns in the R, what is the R code?
Dimensions or dim.
What? N row and column. Another one? DIM, dimension. Okay. So same thing in here, just np.shape. Then if you want to take a look at the first 6 rows, so this is the as at d1 dot head. Okay, d1 dot head, this is the data. Question number 6 is asking you, you have a data that has been written in this format. Let me write it in there. So suppose your data looks like this. Your data looks like this is ID variable, this is WT variable, this is age variable, this is waist circumference WC, this variable. But you want to order them in a alphabetical order. You want to put age first, then ID second, then WC third, then WT fourth. So that means variable name should be in the alphabetical order instead of a random order. Okay. How can you do that in the data? How can you do that? That should be done by using this. So question number 6 is asking you to do that way. Now, if you check these things, now see everything is the alphabetical order. This one, if you take a look at that one, the top one, which corresponding to line number 10, EM, or maybe input 10, if you take a look, ID, raise, income, age, this format it is coming. On the other hand, input number 12, if you take a look at that, the age, arms, BMI, everything is coming now alphabetical order. So what is the code? Code is line number 33. Okay. So if you have a data set in which the name of the variable are appearing in a random manner, if you want them to be arranged in a alphabetical manner, use this one. D1 dot short index equal to 1. Index equal to 1 means column. Index 1 equal to column. Index 0 equal to row. Understand? Are you understanding? Okay. So now question number 7 is asking you, sort the name of the columns of the D1 data by descending order. Now descending order, what should you do? You just write the ascending true and ascending false. Then it will be in the descending order. Now if you take a look at the data, and change it to S2 and see the result, now descending order. Okay. Now it is in the descending order. Okay. Now it is in a descending order. Question number 7 done. Sort the D1 data frame by age variable. You have a data, on that data there is a variable. You take one variable and you want to sort the data by descending order of the values of that variable. Remember, values of the variable. So for example, I have a age variable. I want to sort the entire data frame by age variable so that age appear from smallest to largest. Okay, age appear from smallest to largest, which is this one, age variable. Currently, take a look at the age variable. Currently, age variable is appearing on the input number 12, age 9.35, age 10.34, age 10.28. But if I run the line number 43, and then if I check head DS S3 dot head, then take a look. Now is coming in a ascending order. Are you seeing now is value change, right, from previous one? Okay. So how can you sort the entire data frame by a variable? That could be achieved by running line number 43. Okay. Now I want to sort the data by two variable instead of one variable. How can I do that? That should be done by writing variable the format I want. I want first sort the data by ID, then sort by the age. That means if there are similar ID 111, then all 111 will come, and corresponding to 111, all age variable will appear. And then 222, all age variable values will be in there. That's the way the variables could be sorted with respect to data frame could be shorted with respect to two variable. Let me see you. Okay. So now that is a, this is what you have for the two variable. Now question number 10. Question number 10 is asking you sort D1 data by age and ID variable with missing values. Okay, so now suppose in your data, there is a missing values. You want your missing value to be in the top, or you want your missing value to be in the bottom, like in the bottom. How can you do that? So that is what question number 10 and 11 are telling you. Sort the D1 data frame by age and ID variable with missing values appearing first, and name this as a shorted, name these shorted data as S file. Okay. So what we do in here, question number 10, only difference is that I have written here NA dot positions here. NA dot positions I put here first, and then ascending, I said yes, ascending. For example, if I put here first one is ascending, then they will take first one ascending and then next one is descending. That could also happen. Okay. So now you have seen how to sort the data where missing value will appear in the first rows, in the first, and then missing values could also be appear in the last. That could be done by just running line number 58. Okay, so here is the thing. These are all of you are seeing one line of code, right? One line of code is doing a lot of things. I do not know how many of you have experiences of other things like Excel, sorting, and then SPSS. When we did SPSS in 20 years ago, there is a window-based, all window pops up. We have to specify this and that, and then we have to run it, and then data is created. Now you see just one line of code, right? And some people sitting behind the scene, they are destroying their personal life, pleasure life, all of these things. They just like to enjoy their life by coding, by writing something, by answering people questions, right? So that's the way things is getting very easier. Clear, right? So see, by running altogether, maybe how many lines of code? Maybe altogether 11 questions, right? Maybe 12 lines of code or 11 lines of code I have run. So we have already seen a lot. Okay. Now question number 12. Create a DF1 data frame from D1 data by selecting only first rows. Okay. Why selecting the first rows? Let me explain these things. Are you seeing this is what? A longitudinal data, right? What is the definition of the longitudinal data? The definition of the longitudinal data is repeated measurement would be in there. For example, let me write something in there. So let me write something in there. Suppose what is longitudinal data? ID, okay, age, and then weight, and then height, okay, IG. So ID equal to suppose 1, and he is appearing at age 9. His height is 5.1. And then weight is suppose 210 pounds. His ID is 1. He is appearing again 1 year later. His age is this 10. His height is 5.2 and weight is 220, something like this. Again, he is appearing at 11. Okay. So repeated measurements or longitudinal data or panel data. Remember, 3 words I have said. Repeated measurement data, longitudinal data, or panel data. That means a person is measured repeatedly over time. Okay, that data is called the longitudinal data. From this longitudinal data, I want to select the first visit of each person. This is the first visit of the person with ID number 1. Similarly, there is a second first visit for the second person, right? So I want to select first visit of each person. I want to visit first visit of each person. How can I do that? Here. Here. So this is the, okay, one condition for subsetting the data by selecting only first visit of each person is that you must need to sort the data before applying the code for the first visit selection. So I write here, taking only first visit for each subject, data must be sorted by ID and age variable. So that is why line number 64, I first run, and then after running line number 64, then we have to run this. Are you seeing here? I wrote here in line 20, I sorted the data by ID and age variable in ascending order. This is the sorted data. From this sorted data, I drop duplicate. S7 dot drop underscore duplicate, subset ID by ID and keep first. Understand? Keep first. So drop duplicate. So why we need these things? You might ask me question. Hey, professor, this is longitudinal data. Why are you selecting only first visit? Because once you will give a longitudinal data, first visit is the base, right? First visit base, like what is his cholesterol, what is his weight, what is his height, what is his sugar level. So before going to analyze the entire data, you can do the base analysis. First visit analysis. You said first visit, his cholesterol level is this, his height equal to that, his weight equal to that. That is why each person first visit, you are subsetting one data and you are doing an analysis for that. And then you can also do the last visit. 10 years follow-up visit, 10 years we follow 2,000 people, last visit, 10 visit we see, now we compare between these two things. How their histogram look like. First visit histogram of the cholesterol, 10 visit histogram of the cholesterol. Understand? So first visit history of the smoking, 10 visit history of the smoking. The smoking proportion went up or went down. Okay, in order to do the base and last analysis, you have to subset the data by running the line number 64 and 65. Okay. Alternative approach I have also written in here. This is also alternative approach df1. So if you write np dot tape and df1, you will see significant reduction. So 2379 persons, their first visit appear. Okay, their first visit appear. Are you okay? Are you understanding? Okay. From tonight or from tomorrow, start doing this homework. Okay. Lot of materials is in there. First of all, read the two documents thoroughly. Okay. Read the two documents thoroughly so that you can match the code. Then apply the same code for the new data and new variable. The difference of this homework is that the homework one is just the data is different, variables are different. Everyone is okay? Everyone is okay? Okay. So those of you who does not know how to type without looking at the keyboard, there is some game, typing master game, that is very important. Okay. Nowadays, once you will get into the job, you have to answer a lot of emails in each day. Okay. Lot of emails you have to answer each day. So this is a time to learn all of these things. I did not know how to type. When I came 2006, I see some American kids are typing. I just whisper one, how did you learn how to type? And they said, this is the game, we do these things and we learn. And they learn it from the school. So I got it and practiced 4 or 5 days. Okay. Question number 13. that is the last visit. That is the last visit. There are two types of code I have written there. How to select last visit. That is what you can run either line number 73 or line number 75. Okay. So now my data says D1 has how many variables? How can I find that? D1 dot columns. My data set has, these are the names of the variable. ID, race, income, age, smoke, SBP, systolic blood pressure, DBP, diastolic blood pressure, and then HT height, WT weight, WM waist measurement, body mass index, visits, sugar level, chest measurement, hips, arms, total cholesterol, triglyceride, LDL, HDL, pulse, waist, number of log, time, and event. Number of logging means he has electronic devices. He has, what are the electronic devices? He has a cell phone, iPad, and computer. How many times he is logging in his devices? Okay, and then time to event. How long he is logged in the system, and then event, like there is a yes or no event, something like that. So then data type, what type of data? This is the data frame which we see, pandas score frame, data frame. Okay, now if I want to find D1 dot information, checking the variable types, I want to see how the variables types are. This integer, numerical, continuous, discrete. How can I find that? This is the way you can find it. Okay, so float means continuous and integer means integer data. So in our case, we have integer data and float data. That means continuous or quantitative data, and then another one is integer data. Okay, so race is considered here integer, but race is a categorical variable, but they are considered it as an integer in here. But when we do the predictive modeling, we will change it. We will change it to the categorical yes, not a variable types. Okay, cancel. So how many of you watch my videos? Did you watch my videos? You are watching it, right? Okay. So I will again upload this whole video, okay? This is already uploaded in a 2 separate video, but this video will be unique one video. Okay. If you want to take a look at the first 5 rows, D1 dot head, last 10 rows, this is D1 dot tail. Okay, head and tail. If you want to take a look at 100, this is the way 100 you can. There is a way to write the code. You can see maximum number of line I want to see. Then if you specify that things, it will show up. It is somewhere in the code, okay? Now let me tell you one thing. Nowadays, becoming proficient is coding is no more a skill set to add in your CV. Because of what? Everything is in the online. Now all employer assume that you know some kind of coding, either maybe R or Python or Java or maybe Excel or maybe Visual Basic, something like this. Understand? 20 years ago, 30 years ago, all around the world, maybe there are altogether 100,000 programmers. In mid-90s or 90s, there are altogether maybe 100,000 programmers all over the world. Not 100,000, maybe 10,000, maybe 10. In entire Bangladesh in 90s, maybe 1 or 2 programmers. Do you understand? Limited. But now everybody can write a program. He does not know anything, write any C++. But if you want to write one C++ program, hello world, if he just go to the YouTube and write C++ for the novice programmer, he will see from beginning to end what to do. What to install, how to run, how to do. Do you understand? Okay. So become proficient programmer. Now, question number 18 is telling you what? There is an ID variable, but from the ID variable, I want to create a new ID variable, okay? So are you seeing in here? Are you seeing here the ID variable? This is called the ID variable. So if you know the ID of the students, you can know his grade or any other thing. For example, in Google Human Resources Department or Payroll Department, Google has altogether 65,000 employees. Each employee has a unique ID, right? Unique ID. So the payroll persons who are giving salary increase to these persons, that person, all of these things, they have to write a program and then they put a certain percentage. Okay, this will go 11%, this will go 5%, rest of them will go 3%. That's the way payroll, they do not do everything by manually. Understand? Manually enter few people, maybe altogether maybe thousands people, he will get 3.7%, you will get 4%, all of these things, and they mention those things and they get a match. But the guy who work in the payroll, if he know the ID of the employees, okay, he can disclose their salary increase, right? So in order to stop that things, the manager, the data science manager who is working there, he de-identify the data. How? He create a new ID variable. Existing ID, if you subtract 1,100, then you already know, because I am the head of the data science department. Okay, I am the head of the, so I have all the employees payroll sheet. What I did, I know their ID. I just took out their name, first name, last name, social security number, everything I took out from there, and they have an ID. With each ID, I added 1,000, and now ID will be new ID, right? Or I put another number so that nobody knows, only I knows. And then I give it to the junior data scientist. Okay, this is the data. Now you go and update these things and update the salary informations. Understand? So how can you do that? You have to create a new ID. So take a look what I am doing. I have an ID variable in here. This is the ID variable. I am subtracting for 49,999 from each of these. Okay. From each of these, I am subtracting 49,999. So I subtract these things. New ID variable has been created. See, let me explain these things to you a little bit more. D1 is my original data, and in this D1 or data, I am adding a new variable, new ID. New ID is the variable that is created with D1 data. How? I take the original ID variable, D1 is my data, period ID, original ID. From each ID, I subtracted 49,900 and I got a new ID variable. Now take a look at this D1 dot head and then see, I got this ID. Previously, that was my ID, 50,000. Now ID is 111. These people has the, this is the same person. How I know same person? See, ID is this, but age is different, right? Age is 1 year apart, 1 year away. Okay, so repeated measurement. So the first person is measured at age 9.35. Again, he came, show up. We took all the important health metrics, health measurement at age 10.35, age 11.28. Clear? Yes.
So the ID is not unique there. So based on what is the ID? Usually,
ID is unique for each person. Okay. So now if I delete this ID, now I have that data, right?
yeah.
So that data, if I give to the any person of the human resources department, he cannot identify by this number to the employee. Because that key 49,999 only I know. I do not want people personal identity to be disclosed. You got it? You still have a question? Okay. This is a repeated measurement data. Same person appearing multiple times. So this guy has a ID number 50,000. Same guy, ID number 50,000, 50,000. But how do I know this is the same guy? Because their measurement are taking at different ages. Same guy, measurement are taking at age 9.35. Same guy, measurement is taking 9.34, right? So by this ID, the employee itself know his ID. Okay. But if I change it by subtracting this new ID only I knew, but the guy who are working under my supervision, he does not know. Okay. So now I have given him important information. These are the same team member. He got 10% increase. He got 2%. He got 2.
So you're writing the original ID and what do you call displaying
fake ID, which only I know, but nobody knows.
And
it is also known as the NDA, non-disclosure agreement, non-disclosure agreement. Down the road, when you will work in a team, suppose under one manager, 5 of you are working, so you will get 7%, another one will get 2%. And they will tell you never share your salary information. If you share it, that means next time you will be punished. 2 persons working in the same company, I know them. They came to my home when I was doing finishing PhD and working as a postdoc fellow in NIH. One of them did PhD with me, another one did PhD another place. One guy is getting 140, another guy is getting just 90,000. I'm talking about like 2013-14. And then we are sitting in one places. I was asking, what is this salary? The guy says that we cannot disclose our salary because we work on the same team. Okay. And then later, once it is done, when I went out, he came in privately, I asking, then he said that I got almost 140, but he is not getting any salary increase or something like this. Okay. So that is why he did not disclose. So the rationale is ID variable exists there. From the ID variable, I created a new ID variable. Now I delete the original ID variable. Are you seeing line number 104? Delete D1 and ID. Line number 104, I am deleting original ID. Now if you do these things, D1 dot head. Are you seeing ID variable in there? No ID variable, right? Now I have this new ID. Now these data I can give to the person. Understand, right? ID variable has been deleted. Now these data I can give to the person. Online people, are you understanding?
Yes.
So now the question number 20 is asking you to find the summary statistics of the data frame. So D1 is my data. From that data, I want to find the summary statistics of the entire data frame. So that means each variable of the data frame should show like summary statistics, which I am now seeing. Okay. So this is another options. If I want to see summary statistics of a particular variables, so summary statistics is usually well suited for quantitative variable. So SBP stands for systolic blood pressure, DBP stands for diastolic blood pressure. If I want to see only the summary statistics of the two variables, SBP and DBP, that can be achieved by running line number 111. Okay. So line number 111. Now, what is SBP? So if you go to the doctor take your blood pressure, right? Blood pressure measurement, right? So have you ever done blood pressure measurement? Yes or no? Yeah, right? So two measurement, right? One is high, one is low. High one is called the SBP, systolic blood pressure. Low one is called the DBP, diastolic blood pressure. If a person identified with high blood pressure, both of the reading is high. Okay. SBP and DBP, both of this is high, then the person is called to have high blood pressure. On the other hand, both SBP and DBP is low, then the person is said to have a low blood pressure. So you understand what is SBP and DBP, right? systolic blood pressure, diastolic blood pressure. If you want to find the summary statistics of only one variable, then just write D1 dot describe parenthesis and name of the variable. In that way, you can find the summary statistics of one variable. So now how can you find the summary statistic? How can you find the missing values for each variable of the data frame? Data frame is D1, and then from that D1, there are 24 variables. I want to find the missing values for each of the 24 variables. If I run the line number 119, I find that race has a 0 missing, income has 1158 missing, and smoking has a 9889 missing. Highest missing is occurring corresponding to LDL, which stands for low density lipoprotein. HDL and LDL. LDL stands for low density lipoprotein. HDL stands for high density lipoprotein. Okay. Now question number 23. How much time? 40 minutes. So I have how many minutes? 1 hour 20. I have 1 hour 50 minutes to finish all of this. Okay. Okay, now create a variable and miss for values corresponding to each row of the D1 data. What does this mean? Suppose this is my data, race, age, SBP, and DBP, all the way new ID that I have created. Okay, and this is the variable. This is the row 1, row 2, row 3, row 4. So for example, in this case, this is a missing, this is not missing, this is missing. All of those things are not non-missing. So I want to find a and miss variable in here. I want to find that there is a 2 missing, because this is the missing, this is the missing. I want to create a column like this. Okay. So for example, line number 4, no missing at all. So there should be 0. So I want to create a column and miss that will represent number of missing values corresponding to each row. Okay. So that could be done just like this. And if you take a look at now D1 dot head, you are seeing the row number 1 has 1 missing, row number 2 has 4 missing, row number 3 has 0 missing, row number 4 has 4 missing, row number 5 has 0 missing. Okay, one line of code, right? One line of code. Python has the highest number of users. Lot of packages in there. Okay. So any machine learning, artificial intelligence, those things, research are done by the computer science people. There are very rich library for artificial intelligence, neural network, machine learning things in the Python. Okay. But for statistical methodology, it is always good to use R, because the people who develop statistical methodology, they are very good in R. They write the packages and everything in the R. Okay, now next question is question number 24 is asking you any row that has a, suppose this row has a missing value. This row has a missing value. So this row will be deleted. And this row does not have a missing value. We will keep this row. Any row that has a missing entry, that row will be deleted. Okay. So after that deletions, I will have a complete data. Complete data means the data that does not contain any missing entries, more specifically. Okay. So to do that, the line number 127, if you run just D2 equal to D1 dot drop NA, then this will give you the results. Okay. So all the syntax and things that you are saying, some other people develop, we are just slave. We are using what they are asking us to do. Okay. Most successful persons on the planet is Steve Jobs, because he made each and every individual on the planet as his slave by coming up with the touch phone idea. Apple iPhone 2007, when it first came. I still remember that day. Okay, the people, it was in winter day, people were rushing to the AT&T and Verizon place, not Verizon, AT&T place with the blanket to get their 3G Apple phone. Okay, so each and every human being is now using touch phone, smartphone, right? Except like Putin or some other people, they do not use any smart devices. They always still use their analog devices. They don't want to be traced. Okay, so now take a look the shape of the data. So now 1942 rows and 26 columns. Okay, so after deleting the missing values, we got this. If without deleting missing values, what we are getting? It was 20,900 rows. Now, when I delete any row that has a missing value, I got 1942 rows. Now, as D2 is the complete data, that means there is no missing entry in the data frame D2. So we can take a look at the summary statistics. And that's the way is difference. I have done a complete analysis with the complete data, no missing values. I have another analysis, there are missing value. Here is the difference. Okay. Now, how can you find the standard deviation for each variable of the D2 data? Just run the line number 139. Here is the standard deviation for each variable of the D2 data. See, if you use the complete data, there is missing value is in there, then the standard deviation is 2.99, but with the complete data, standard deviation is 1.15. This is very interesting. I want to find the standard deviation for the standard deviation means what? Can anyone of you tell me what is standard deviation? What is standard deviation? Can anyone of you tell me?
Deviation from the value of the variable.
Deviation from the mean, well, approximately correct, but
Median and more.
okay. Uh-oh. Let me write it in here. So take a look. This is the definition of the standard deviation. Oh. Okay. Let me write the definition. Average distance of each data point from its average is called SD. See, distance of each data point from its average. This part is what? This part is xi minus x bar, right? So distance of each data point from its average is this one. Then I say average, right? So this is the distance, I'm squaring it. So that is why I have to neutralize these things. I put here square root. Okay. And then this average is what? N minus 1. Now the question is, I am summing here n terms, but why I am not dividing it by n? Why I am dividing it by n minus 1? Are you understanding? Average means what? If you add 5 numbers divided by 5, right? You add 2, 3, 7, 9, 10. These 5 numbers you have added. So and then divided by 5. 5 terms you have added, you divide it by 5. But here you are adding how many terms? N terms. Why you are adding n minus 1? Why not n? Okay. So this is mathematically proved. This is mathematically proved. Okay. Mathematically proved. So in order to prove these things, this formula should be. And what is the definition of this? This is called the unbiasedness. Unbiasedness. Okay. So anyone ask you what is standard deviation? Average distance of each data points from each average. Okay. In the video link that I have provided, there is also one lecture video where I explain why that is a long video, maybe 1 or 2 hour long video where I have explained and give a mathematical explanations as well as give some numerical example why standard deviation is important. Okay, so the question number 27, what we are doing, we are in the line number 41, we are considering race, income, smoke, and breast. So that means chest measurement and waist and event. Those are the integer variable or categorical variable. I do not want those variables in my data. Clear? So I just write it as a irrelevant. And then I write a new variable relevant and read the line number 142. Variable for variable. In D2 dot columns, whatever variables are in there, if variable not in the irrelevant. When I first saw these things and writing these things, I was laughing. This is just the pure English, right? Pure English, right? Variable for variable in D2 dot columns, if variable not in the irrelevant. So that means D2 dot columns keep all the variables that are not in the irrelevant. So and then you can find the standard deviation for the all quantitative variable. Okay, now this is the way you can find the standard deviation for each variable. This is the way to find the mean of the SBP variable. This is the way to find the minimum of the SBP variable. Okay. So you just took the D2.SDT.SBP. Okay. On the other hand, in the R, how can you write this? You write mean, and then you write D1 and $sign SBP. But now if you hit this, you will get nothing. Okay. This is the way you have to write the code in R. But here you have to declare the data first, and then you have to specify the functions that you are computing, and then finally by putting a period, you have to specify the variable you are interested in. Now, what I want to do, as I mentioned, SBP and DBP are the two blood pressure measurement. One is high, one is low. I want to find the average of them and want to create a new column. So this is the data. So suppose this is the data. It starts with the A's, raise, SBP, DBP, and I want to find the ABP, average blood pressure, by averaging these two. This plus that. This plus that will be in here. This plus that. This is the first person. This is the second person. This is the third person. This plus that. This plus that. I want to find a variable in here. It is, I'm showing you how to add two columns actually. But in the real life, if you do some analysis by adding the SBP and DBP, people will laugh at you. Understand? That is not average blood pressure. Average blood pressure will come. Average of SBP will be average blood pressure. Average of DBP will be average blood pressure. So average SBP is this average. Average low blood pressure reading is 90. Average high blood pressure reading is 85. But you average these two things, people will laugh at you. It will not be acceptable. Okay. But for the purpose of learning how to add two columns and create a new column, I have done this. So I have selected SBP and DBP, and I then run the line number 154. Take a look. 154 is running what? Initial is this. I find the initial dot median. Okay. If there is two numbers, mean and median are the same, right? So suppose you have 20 and then you have 50. What is the mean of this? 20 plus 50 equal to 70 divided by 35, right? This is the mean. What is the median? Also same, right? Median also same, because you have to add these things and divide by 2. So that is why, even though in the question I said mean, find the average, but here I write the median. And x is equal to 1 means always column. If you put x is equal to 0, then it is row. Okay. So I found this. Let me show you the data now. Let me show you the data. D2 dot head. And here is the ABP. ABP has been created in here. Okay. I think Ololadi and Charity as well as Shafali, you are taking my 435 as well, right?
Yes.
Yes.
So Shafali is not taking my 435. Did you take 435 before?
Yes. Dr. Man's class.
So Shafali, you take 435 before with me, right?
Yeah. No, not with you, with Dr. Man.
I'm not hearing. I'm not hearing. What happened? There is some problem in there. Let me see. Can you speak now?
I took Dr. Man's class.
Oh, you took with Dr. Mans.
Man. Yeah.
So is this the first class you are taking with me?
Yes.
Okay. So you don't need to. How about Charity? You are taking with me 435, right?
Yes.
Okay. Sami, you are taking any course with me?
No, this is my
Sammy?
first course with you.
You are just taking 480?
This is my first course with you. I've taken 435 and 535 already.
Oh, this is your first course with me.
Yeah.
And Oluladu, you are taking, you already took or you are taking 435 as well?
Yeah, I'm taking 435 now.
Oh, 435. Okay. So last 10 minutes wait. I have a new homework for you. Okay. Because same homework you cannot do and get credit for 435 as well as 580, 480. Understand? I will give you clustering problem or classification problem. I have problem code, everything ready. And then I have also the video. Okay. Why I give first two classes, all graduate level, I keep the same material because this is the material will give you basic training for the Python. Clear, right?
Yes.
Yeah, I see some faces are gloomy, but I like gloomy faces sometimes. All times I do not like very laughing, happy faces. That's good. Okay, so we will spend few minutes. So then I just took the three variable and want to see all the three variable together. So this is the SBP, this is the DBP, and this is the average of this. This is the way we can get. So now I want to tell you one thing. The next question, next problem. That is a question number. That one. See, the question number 30 that is in there. I have ABP. From ABP is a continuous variable because ABP is coming as the average of SBP and DBP. From there now I want to create blood pressure category variable. So blood pressure category variable, how can I create? I can create, it will have a level 1 when ABP value between 100 and above. If 100 and above, for example, this value 100 and above, then I want to put here category 1. Here, category 1. 85 and below 100, then it is category 2. By using this continuous or quantitative variable, I want to create a categorical variable. Now, let me explain how I have to do these things. So line number 161, I am finding the maximum of this line is telling you that go to the ABP values of the D2 data and find the maximum of that. And within the maximum, I am adding one unit. If you do not add it, that's fine. But if you add it, that is also fine. Why? That is the highest limit of the ABP. Now, I want to create a level 3 when ABP value 0 to 85. Level 3, these three, are you seeing 3 in there? These three will take ABP value 0 to 85, then ABP value equal to the blood pressure category value equal to 3. If 85 to 100, then blood pressure category equal to 2. 100 and above limit, then it is equal to 1. What is above limit? Above ABP, average blood pressure limit is this one, highest value of ABP plus 1. I have included 1 in here in order to make sure that highest value of the ABP should not be cut off. That is why I added in here. If you do not add it, that is still fine. Now, this is a blood pressure category range. Okay. And this is the blood pressure category level. And then how can I create a new variable BPC? In the D2 data, I am creating BPC variable PD.cut. From the D2 data, I am taking ABP values and putting it in these bins and finally included lowest equal to false, right equal to false, and levels equal to BPC level. BPC levels like this. That way, the ABP value will be transferred to the blood pressure category variables. Now take a look at the thing. Are you seeing 2? 85 to 99, 100 and below, then 2. 100 and above equal to 1. 100 and above equal to 1. So this is the way any continuous variable you can transfer to the categorical variable. Clear? So what you have learned from the line number 161 to 172, what have you learned? You have learned, suppose your manager told you, this is the income level, income variable of our 65,000 employee at the Google. Okay. I want to make a 10 category. Category 1 falls below 50,000. Category 2 falls 50 to 70,000. Category 3 falls 70 to 90,000. This is the way you are given level as well as the range values. How can you create those things? You have to run line number 161 to 172. Clear? Okay. Very important, these things. Why? Many times in your life, you need to do the predictive modeling where you need to create an independent variable that will have a different levels, and corresponding to each level, you want to see a prediction. When level increases 1 to 2, what is the odds of happening an event? What is the odds of incidence of the events? Understand? So even though you have a continuous variable, it is better to predict the response variable in terms of categorical values instead of a continuous values. Understand? So these lines of code is very important. And now suppose you want to subset the data by selecting total cholesterol. TC stands for total cholesterol. Line number 176, TC stands for total cholesterol, and WT stands for the weight. You want to subset the D2 data where you want to pick the subjects who has total cholesterol value greater than 162 and weight value less than 62. Weight value less than 62. Okay. So this is the way subsetting the data. Suppose you are working in a Google and Google health department who provide the breakfast, lunch, and sometimes dinner for the highly paid or very important persons. They have their cafeteria. Okay. They have their cafeteria. People go there, eat there, and they want to provide the healthy food. Okay. And then now want to find like the people with total cholesterol greater than this and height, weight is greater than that. You suggest them these people should eat this type of food. Understand? So you can subset the people from there, all 65,000 employee, and you can say that, well, according to our dietetics and our health scientists, they suggested you to eat this and that type of food. As a data scientist, you have to find the people, right? You have to find the people who are obese, who have high cholesterol or no. How can you do that? You are selecting two categories. One is total cholesterol, one is weight, and then you are subsetting the data. Now take a look. D2 dot np dot shape D2. If it is written, now it has a 1942. Now if you go there, np dot D21, it is still 1942. Let me run these things. Okay. np dot shape DDT1. Okay, still the same people. Same people. So that means the people whose total cholesterol is 162. This is the people who have the that weight and that cholesterol category. But if you change it, suppose I want to change it to suppose 123, and weight, suppose I want to change it to 50. Now let me do these things and check again. Hopefully this times it will go down from 1942 to, it is still in there. Let me check. Let me do it 100. And let me check it to 40. Let's see if then maybe this things is not working. Maybe let me do another thing. 90. It may be 20. Let's check. Okay, so then that code is not working. I'll fix these things, okay? It is sure the code is not working. For some reason, this AND is not taking. I'll check it. I will fix it. I'll check it. I will fix it. Okay. So now, D2. Okay. I will check it and fix this 176. Line number 176 before I forget. Line number 176. Let me send in line 176. 176. Okay. Now, question number 32 is asking you find the frequency. Okay, frequency. So I want to find the how many blood pressure category is in there. If I run this, we see 3 blood pressure category. There are 126
I have a question.
people. There are 2 blood pressure category, 1100 people, and there are one blood pressure category level with 716 people. So this is a frequency table for the blood pressure category variable. Now, this is the alternative approach of finding the same. Now, I want to find the blood pressure category for the race variable and blood pressure category. So in this case, if you take a look at that, I put here column equal to race, and then this index is coming by the row. So index D2 equal to BPC 3 to 1, and column D2 race equal to 1 and 2. How can I read this? I have to read it race 2 with blood pressure category 3 equal to 63%. Understand? How can you read that? Race 2 with blood pressure category equal to 328. Okay? Clear? Take a look at that. Race 2 with blood pressure category 1 has a 328%. It is called the cross frequency. Okay, it is called the cross frequency. Now, if you want to find the mean by race variable, race 1 stands for the Caucasian, race 2 stands for the African American. Let me check. Yeah. 1 equal to Caucasian and 2 equal to African American. Caucasian means white. Okay. Caucasian means white and African American equal to 2. Now I want to find the, for example, I want to find for the each of the quantitative variable for the race 1 and race 2. Race 1 and race 2, I want to find the mean for the entire data frame. So in order to do that, I first need to run 191, and then after running this one, I have to run this. Now let me explain this. Are you seeing here race 1 and race 2, right? So race 1 has an average income 5, race 2 has an average income 6.53. Race 1 has an average is 13.06, race 2 has an average is 12.91. Clear? You're getting it, right? So I want to find the mean for each variable of the data frame corresponding to two level of the raised variable. Similarly, this is what standard deviation we found. By race, we want to find the mean of only one variable. By race, we want to find the standard deviation of only one variable. That is the question number 35. If I want to find by income, that could also be obtained like this and that. If I want to find the variance for the SBP variable by income, that could also be obtained because there are 9 income level. So we want to find the average variance of the SBP for the 9 income variable. For the 9 income variable. Okay. NP dot shape dot D2. Okay. Let me go to the D2 data again. No, I have to go up. Here is my D1 data. After D1 data, I have to come question number 12, right? Question number... Question number 24. Then, good. Now I want to go question number here. Question number 38 is telling you what? In your data D2, if there is any repeated measurement, I just want to delete that thing. Understand? Question number 38 is asking you if there is any repeated measurement, we have to delete these things. That could be done just by running this. Uh-oh, new ID is not in there. Okay. So let me do another way then. Because I did not write the new ID one. I just want to have the ID. I just do these things. Let me check now the dimension NP dot. You have a question? $1,440. You have question? Okay. So now what I did, D3 data has been created. In the D3 data, there is no repeated measurement, okay? There is no repeated measurement in the D3 data. So now take a maybe 5 minutes break. After 5 minutes break, I will solve all the graphs and other things, okay? Let me drink little bit of water. Let me give a pause in there. One of you give me a reminder that I have to recording. Okay. I started recording the class again. So line number 176 code has been fixed because the parentheses, this parenthesis previously put it in there. Now by the advice of one of your classmates, it is now in there. Okay. So Let me start from now, question number 39. 39 to maybe 50 or 55, it will be all graphical presentations. Okay. So I want to first do the bar chart and pie chart. Bar chart and pie chart are done for the qualitative variable or categorical variable. So there is a raise variable. I want to find the bar chart, first pie chart. So this is the pie chart of the smoker and non-smoker variable. Okay, there is a high number of non-smoker and only a small person of smoker. Now, if you can ask me why pie chart something is coming out, if you do not want this to coming out, just put a comment sign in there. If I put a comment sign in there and take out this explode thing from there, then it will go down. Now, if you run this yellow will not come out, it will be inserted back. Okay, it will be inserted back, so the graph will look like this. Okay, so now this is the bar chart. This is the bar chart for the non-smoker and smoker. And this is the pie chart for the income variable, pie chart for the income variable. And this is the bar chart for the income variable. Okay, bar chart for the income variable. I ask you, you have a 1 week time, immediately jump into these things and try to understand the code. If you have a problem, you can have a Zoom meeting with me, or you can come during my office or physically in order to understand the code. Okay? Yes.
Should we send email you to come?
Yeah, you can email me or you can directly come to my office hour during Monday, Tuesday, Wednesday, 9 to 10:30, 9 to 10:30, and 9 to 10. Okay. Additional office hour I can give by appointment. So smoke variable, bar chart and pie chart, income variable, bar chart and pie chart, I have shown you. Different types of color I have put there. Okay. Now question number 43. If you have any question, just read that document. Okay. These document and then code, if you match, then there should not be any problem. Okay. So that is why I'm teaching it very easy, very naive, and very simple way. I don't know whether you have seen any graduate level class the way I'm teaching. Okay, many of you are seeing Python for the first time, right? Right? And the code that you will submit and homework, when you submit your resume to the interviewer, and during that time they will ask you, you took the Python course, did you, how much you know, could you send us some Python code that you used during your homework and all of these things. During that time, if you submit these things, so that is a do your homework very beautiful way. Write the code with the comments and all of those things. They will ask you, send me their original file. When you attach the original file, and they will check when the file was created. They have a machine, they have a tool, they can identify. And if you create something new for them within 2-3 hours, and the Python file, they will run something and they will be able to identify those things. The package that you have run, they can go there, they can find those things. You do not know how much talented people sitting in there. Security layer after security layer. After that, they hack the important website, right? And they remotely take ransom from Russia, like Georgia gas pipeline. They hack those things, and the people we are sitting in US, we say, how can this possible? You have taken my advice, right? Do your homework very beautifully, save it, write the code. Your employer might ask you, send me your code, one of the Python code or 2-3 Python code that you write. Then what you save today, send it to them. When they open, they say, yes, this file actually written 1 year ago, 6 months ago, 7 months ago. They can do these things. Okay, now I want to, this is a 2x1 plot. Okay, let me explain these things in here. Are you seeing here line number 260, plot, subplot 211. So that means 2 row, 1 column, 1 figure. Okay, 2 row, first row, second row, 1 column like this. So that is why it is written 211. 2 row, 1 column, 1 figure. 2 row, 1 column, 2 figure. 2 row, 1 column, 1 figure. 2 row, 1 column, 2 figure. That is the understanding. So if it is put there 2, 2, 1, 2, 2, 2, 2, 2, 3, 2, 2, 4. That means 2 row, 2 column, 1 figure. 2 row, 2 column, second figure. 2 row, 2 column, third figure. 2 row, 2 column, fourth figure. 2 row and 2 column means how many cell? 4 cell, right? 2 times 2. So next one is 2x2 plot. Now you will see 4x4, 2x2 figure. Okay. Understand? Now this is called the stack bar chart. Stack bar chart means I want to take race and income. I want to see them together. Here is the stack bar chart. AA stands for African American, CC for the Caucasian. What does this mean? Income level 1, this part is for the African American, that part is for the Caucasian. Understand? Income level 5, I5, this part is for the African American, that part is for the Caucasian. Okay? This is called the stack bar chart, and this is called the group bar chart. Same, but different name and different types of display. Okay? Income level 1, this is African American, this is Caucasian. Income level 4, this is African American, this is Caucasian. Understand? If I want to put them side by side, that is the side by side. That is the side by side. Clear? Okay. That is the side by side. Now I want to do the dot plot. Dot plot means observation number and there's value. SBP has an observation number 17. Observation number corresponding to 17. What is the value? So it will go by that. That is called the dot plot. This is called the dot plot for the whole SBP. Dot plot for the African American and Caucasian. 2 dot plot. Histogram for the SBP, 1 histogram for the African American, 1 histogram for the Caucasian, and then box plot for the SBP, 1 box plot for the African American, 1 box plot for the Caucasian. Okay, 1 dot plot for all SBP, 2 dot plot for African American and Caucasian. How many dot plot? 3 dot plot, right? 1 histogram for the whole SBP, 2 histogram, 1 for the African American and 1 for the Caucasians. How many histogram? 3. 1 box plot for the whole SBP and 2 box plot, 1 for the African American, 1 for the Caucasians. How many? 3 box plot. 3 dot plot, 3 histogram, 3 box plot. How many plot? 9 plot. 9 plot I want to put in 1 grid, 3 by 3. How can I do that? That is a 3 by 3 plot. That is by 3 by 3 plot. Okay. Okay. Dot plot for the whole DPP, dot plot for the CC, dot plot for the AE. AE of CC of what? CC of DPP. Okay. Histogram for SBP, SBP for AA, SBP for histogram for all SBP, histogram for AA, histogram for CC. CC means Caucasians. Okay. This is the way you can do 3 by 3 plot on 9 plot. This is what known as the, how many variables I am taking? SBP, DBP, TC, and TZ. This is the plot SBP versus SBP histogram. This is SBP versus TC. So in this case, I see that one is increasing, another is increasing, right? And here, no pattern. One is increasing, other is increasing or decreasing, no pattern is found. Here, one is increasing and other is staying in the same level. So this is increasing, but that one is increasing sometimes in here, sometimes it is going like this. As this value is going like that way, other value is shrinking like that way. So from there we see this and that are the same increasing pattern. This and that does not have a pattern, does not have a pattern. So this is called like 4 variables that I have taken in here, SBP, TC, and TZ. This is the histogram for SBP, DBP, TC, and TZ. And this is the dot plot for the 2 other variables, okay? So, for example, this is the dot plot, this is the dot plot for SBP, and third one is what? TC. This is the dot plot for SBP and TZ, okay? So, this is the TC, and this is TC, so then this is TZ. TC and TZ is this one, okay? TC and TZ is this one. Similarly, this is TZ, and that is SBP and TZ, and this is TZ, and this is TC. These are the same. Okay. It is called the pairwise plot, pair plot. Okay, it is called the pair plot. Any confusions? Immediately read the Word document. Understand? Immediately read the Word document. There is no other easiest way to teach like basic programming to the students who do not have any programming knowledge. If you have any other nice idea to teach this class to the people who do not have any Python knowledge, I will be more than happy to accept that. Understand, Sami? Are you okay, Sami? Okay. So now, this is called the box plot for SBP corresponding to each level of the income variable. Okay. Now I want to do this is some okay. So I have a data. From that data, I randomly select. I want to randomly select now 200 rows. For example, take a look at the D3 data. np.shape D3. Okay, 1440. From there, I want to randomly select only 200 rows. How can I do that? This is the way I have selected 200 rows. So if I write here random subset, this is the way I can see. This is the 200 rows, okay? So if you write here np.shape, we got 200 rows. So what you learn from the line number 5, 11, if you have a big data, very big data, okay? Very big data. With the big data, you don't want to do all the analysis. You randomly take one sample and you have to do some sample analysis. You can say that, well, you have given me a data that has a 50,000 rows. From there, I just took a 1,000 rows and I do this random analysis, summary statistics, box plot, histogram. These are the variable of interest. This looks like that. So I want to feed the model, run the model on that before going to the whole data. Okay. So if I want to do that, line number 511. line number 511. Then if you want to take just a random sample of a variable, then you have to run the code 517, line number 517. Okay. Okay. After running 517, there is a stem-leaf plot. If you want to do stem-leaf plot, you have to do these things. Okay, it is not working. Import. So, what did you say? Line number what?
5 to 6.
It,
5 to 6.
it is not running. Okay, it is not running. So how can we do that? Can anyone of you help me? So there is a, let me see, command line. That can also be done. Pip install. Okay, let me see. I have to take out these 3, right? Let me see. It's not installing. Okay, there is another option. Let me see. Here you go. I think now it will stop. Let me see now. Yeah. So what happened? First install these 2 things. After installing these 2 things, go in here, CMD execute prompt, go there. In there, you have to write pip install stem graphic. Okay. Do you understand? Clear, right? And class is recording, so I hope you will not have a problem. No, I don't want to quit. Sorry. Okay, so you have learned in problem number 59 how to draw stem leaf graph. Okay, stem leaf graph where if there is a number, decimal number go for the leaf and stem is for the non-decimal number. If you put, you will get a graph, and then from there you can. It is similar to like histogram. Okay. And there is, if you can put a curve there, then that curve looks like symmetric or skewed to the left or skewed to the right, something like this. And then question number 60, what I'm doing, I am creating a data set that is named D4 from the D1 data by ignoring variables that has lot of missing values. ID, TC, TG, HDL, LDL, and smoke, waste minimum measurement, sugar, time, and event. These are the variables that I do not want. So do not want them. So I name them as a exclude, and the variable that I want to keep, I name them as a keep, and then I wrote the code bar for bar in D1 dot columns if bar not in the exclude. And then I took the original data D1 and keep and copy. That's the way I get the data. So these D4 data does not have a lot of missing values because the variable LDL, HDL, TZ, TC are the variable which has a lot of missing values. So I excluded those things because now instead of one data set, now I want to work with the 100 data sets simultaneously. Understand? America has how many states? 50 states, right? World has United Nations, how many countries? The member of the almost 200, 195 or 96. I want to work with the 200 data sets of the world together at the same time. Someone asked me, well, I want to find the average longevity of the 200 countries in the world. So 200 countries data set is in there. How can you do that? The programmer make our life very easy, which you are going to see. Very interesting. Are you understanding? Now I am going to work with 100 data sets at the same time. So far you have learned, I have worked with only one data set, okay? Now I will run I equal to 1 first data, I equal to 2 second data, I equal to 3 third data, I equal to 100 data. Then I equal to 1, I want to take first data and find the mean of SBP for that data. At age 9.1, or the people of age 9.1, I want to take them as a one data. At age 9.2, I want to take them, all those people as another data. Are you understanding? At age 9.3, I want to consider all of these people at age 9.3 as a one data. I want to see average blood pressure for the age 9.3 people. I want to find the average blood pressure for the people whose age is 15.3. How many data? 100 data. In order to do that, next few lines of code is very important. So now I want to take a look at the shape of the data. I see 20,900 rows and 17 columns. And then if there is any missing values, I am counting like this. Now I have created a and miss column like this. And from the default data, any row that has a missing, I just delete that thing. Okay. D5 data, let me check. np.shape D5 is my data. 17,025 rows and 18 columns. 17,025 rows, 17,025 rows and 18 columns of data where each entry does not contain a missing value. Okay? Each entry. No missing value to each row. This is a complete data. Okay. After that, see, I said age, right? I am creating new age. So when I run the line number 554, I am creating a new age variable by rounding the existing age to 1 decimal place. So now take a look at the data D5 dot head. Are you seeing new age is created, right? New age is created, okay? 1 decimal place, right? 1 decimal place. Okay, 1 decimal place age is created. Now I want to subset the data age greater than 9 and age less than 19. Line number 558, when I ran, I got a data which is D5 data where the minimum age is greater than 9 and maximum age equal to 19. Okay. Minimum age equal to 9, maximum age equal to 19, right? Okay. Now take a look at that. So this is the data I have created from all the way line 1 to 558. Okay. I am the chief data scientist. I am the manager. I have access all the data. I know all the secrets. Okay. Now I want to export this data to somewhere else. Okay. How can I export this D5 data? You just write this and it will be exported. Line 562, what I did, D5 dot 2 underscore CSV, D5 clean underscore data index equal to false. So that means the data should not contain any row index. Row number should not be created in there. So I exported in data somewhere in my computer. So where is my this data? If I go there in search box, if I type D5 underscore clean, if I write D5 underscore clean, are you seeing it is showed up, right? Data already saved. Where? It is saved in my, I think, working directory. This is the data. Right? Yeah, you can also put it somewhere else, but now it is saved the working directory where I declare. So this is the data. Now you will save it, you will give it to the people who is working under your supervision, okay? Okay, so now you see the data, right? I want to group by the data. I want to split the data by new age. So line number 566, if I run, so D6 is the data that has been created from D5 data. Now I want to see the data corresponding to age 9.1. This is the data corresponding to 9.1. Remember, the 566 is splitting the entire data. D5 is the entire data, which I split by the age variable. So now D6, age 9.1, I got a data. Are you seeing new age written 9.1? So now if I want to take a look at the data corresponding to age 15.5, are you seeing 15.5? Now D6 has how many data? 100 data. D6 is not a one data. D6 has now how many data? 100 data. D6 dot get group 9.1, one data. D6. See, these are the some other people, they develop all the packages, all the code. We are just putting all of these things together. That's the way now. Do you think if internet is not available in there, I could code in Python, in R, in SAS, in Mathematica, in MATLAB? No. Whatever you want, need, you just search, you will find it in the Google. Okay. So at my home, in my car, if anything needs to fix, like the simple things, I always just Google and I always fix it. And my car windshield was broken, and then I took somewhere, they said that, well, it is better to replace it. Otherwise, it will cost you more damage, maybe more accident, it will harm you. They wanted to take $600, $700. Just one impact of the small stone, small rock, okay? I saw the impact. Then I Googled, I said, oh, this is a small rock, just go to the Walmart, buy these things and put it. And believe me, I did the same thing. My windshield, car windshield is doing perfect. Okay? So if you run code, if error comes out, copy the error and paste it in Google, and then they will give you. Believe me, if there is no Google, there is no internet, still there could be altogether maybe 5,000 or 7,000 programmers all over the world. And people will be efficient with just only one, either Java or C++. What I have done today, if you give me maybe 2-3 days, I will write everything in the Java or in the C++. How? Just from the Google. I'm not afraid to speak the truth, and it is absolutely truth what I'm saying. So there is no argument against absolute truth, right? I'm a man. There is no argument about these things. So now you have seen now how D6 become a list of data. Okay, so now that thing is done. Now if I want to check the length, so I want to see the length of D6, 100. D6 is a list now. That list means what? It has a lot of things. List, LIST list. Like 30 years ago, when your grandparents go to the shopping or in shopping, grocery shopping, so your grandma write all of these things, right? He write all of these things in the list, and he go and open the list and buy each and everything. So D6 is your list. It has a 100 data. D6 is a list. So now D6, you see 100 data. Now see what I'm doing. That's the fun starts. This is just some thing I want to check the dimension. So for 9.1, I have 60 rows. 9.2, I have 90 rows. For the data that has a age 9.1, so I have a data corresponding to age 9.1. I have another data corresponding to age 9.2. I have 100 data corresponding to age 19. So data corresponding to age 19 has 119 row. Data corresponding to age 18.9 has 147 rows. This is the way I compute all of these things. Print sum D6 dot size. Okay, D6 dot size. Okay, now this part, it is called the single loop or for loop. Single loop or for loop, question 70 and 71. Take a look. Rows for underscore, rows in D6. That means each row in the D6. And D6 is a length. Okay. Import statistics as SS. Data list. I just name it as an empty list because after computing all of those things, that should be added in there. This is now empty data list equal to this. Now for I in the range in length of DS. What is DS? DS is in here. DS is considering the rows in the D6 data. D6 is a list which has a 100 data sets. And that is why I put here I takes value range length 1 to DS. After finding this, then I am finding the age and finding the S dot mean. S dot mean. SS dot mean. SS stands for statistics. Statistics mean find. And are you seeing DS? I equal to 1. That means take the data corresponding to age 9.1. I equal to 2. Take the data corresponding to age 9.2. I equal to 100. Take the data corresponding to age 19. That is the way for loop is running. And then this is all the for loop after running in here. And I am putting it in the data frame format. This data frame format is in here. Data frame format is in here. And then this one goes with this one, that one goes with this one, and this one goes with this one. All the parentheses, and I am adding all of this, appending all of this to that data list. Okay, and finally I am getting the result as a concatenate format. So if I run this, this is the results. Now take a look at in here. A is 9.1 mean SBP. A is 9.2 mean SBP. Right? So in this, so if you go 9.1, 9.2 up to 19, so 100 data sets. So suppose there must have a data sets in the World Bank data bank. That data could be unique data with the world population. And each country, there is a many years of data, many years of data. And then you just split the data by the country, like the way I split the data by age. Understand? If your manager, someone asks you, I have this data and that many state, 36,000 American cities, I have all the populations. I want you to find the mean of longevity for the people of 36,000 American cities. Are you understanding? Don't fall from the sky. You can say, oh, that's easy. It's line number 588 to 602. Okay? Just tell your manager, oh manager, it's easy. It's just 12 lines of code, 15 lines of code. Okay? And if you stuck, you email me, I am here. You understand, right? 50 states, and you want to find the longevity of the people by gender. You want to find the longevity of the people by race. You want to find the longevity of the people by income level. All of these things, just line number 588 to 602. Are you understanding? Lot of materials have been given in one lecture, because rest of the lecture I have to cover a lot of predictive modeling. I did not spend more than 2 weeks for the training of the Python. And rest of the homeworks, you have freedom to use either Python or R. Okay? So you have seen these things. How can I do the same thing without using for loop? Some people do not like. For loop is slower sometimes. So D5 data I take by group by. This is the another approach. Okay? I did not use any for loop approach. I just put these things in here. So there is an aggregate function I put. You can also alternatively use just these things. But you have to use the group by thing. D5 is the data, and you group by new age, and then you find the aggregate, and then you find the mean, median, minimum, maximum, all of these things, you will get this. Okay, so let me run this. That is the another approach. Here, instead of finding mean, I found different types of computations known as the mean, median, minimum, maximum, and standard deviation. But this should be keyword. This should stand there. I want to aggregate, group by new age, aggregate SBP, find the mean, DBP, median, this dot reset index, and finally got the printing. And this is the third approach where we have to write some function and finally call the function. Then you will also get these things. Why I did not get it in there? Okay, so maybe I have to put here 6, maybe, let me see. Test one is not defined. Let me me see whether I have to. Okay, let me first do these things. Let me see whether this one runs. This one runs perfect, right? So that means test one is running D5. If it is not running D5, okay. So here is the thing. I got 4 quantity in here: mean, minimum, maximum, and standard deviation. Okay. This 4 quantity I got it in here for. This is what I got for entire data, D5 data. Now let me plug it in here D6. Let's see whether D6 will work. D5 works. Let me see D6 work. D6 is the. If it will not work, then there should be another approach. Okay, D6 is not working in here because that was in the list format. Let me see whether this one will work. By rating. Oh, come on. Okay. What they are doing, they are considering only one instead of all of this. Okay. So the functions is different approach for overall measure. So this is giving you the overall measure. The function is not working here for each data sets. For overall data sets, function you can apply. Okay. How many minutes? 15 minutes. Let me finish. So this is the double loop one, but there are sophisticated double loop things that maybe I can discuss. Here it is just the very naive, simple one. I took 10 rows and 10 columns, and I find the grand mean of these 100 values. And then from each entry, I equal to 1 and j equal to 1. That means first row, first column, subtract the grand mean. In that way, that naive approach I have used in here. So we should not be worried about this one. So this is the double loop one that I wanted to mention. 10 rows, 10 columns I have taken, and then finding the grand mean. And after finding the grand mean, we are just subtracting the grand mean from them. So this is the without double loop. D4 is not defined. I can make here D8. It's all right. So if I change it to the D8, if I change it to the D8, it will work maybe. Oh. Yeah, now it will work. Yeah, here you go. So when I put here capital D4, which was not appropriately defined. Okay. So I'm very close. Let me explain one thing. So data in this format, suppose. Data is called the long format data. Long format data. Long format data means what? So it is ID variable, and it is SBP, it is age, and it is suppose height and weight. This is the data. This is the ID, first person, first person, first person, second person, second person, second person, second person, third person, third person. So this is the data. So I have data in this format. So this is the values, all the values is in there. Okay. So what I want to do, this long format data, I want to make as a wide format data. Wide format data. Wide format. So person one. So then first variable is ID. Okay, I put here his ID is unique. Person 1, his ID. Suppose ID equal to I1. Okay, then I want to put here SBP 1, SBP 2, SBP 3. Because first person has 3 ID. So I put 3. Then I put here age 1, age 2, age 3. Okay, then I put here height 1, height 2, and height weight 2 and weight 3. So this is one person's all the data in one line. Then I'm coming second person, all the data with ID I2, all the data in here. So this is called the long format data. This is called the wide format data. Sometimes some analysis, statistical analysis, wide long format data needs to be transferred to the wide format data, and sometimes wide format data needs to be transferred to the long format data. For example, if there is a bioinformatics things where like sample is in here, first sample, second sample, third sample, but gene 1, gene 2, gene 3, gene 4. In such a cases, pairwise t-test could be better done by using the wide format data instead of the long format data. Okay, now next 2 lines of code, we are going to discuss how to transfer short format data to long format data. So now here is the new ID. As I'm taking D1 data does not have the new ID. Instead, it just has the ID. Uh-oh. Uh-oh. Okay. So original data is D1. From there, I took ID variable, visit, and SBP. These are the things I have taken. ID, visit, and SBP. ID is not found, D1 data. Why? Why you are making fun with me? Let me run this data again. Okay, now come down to that place. Here you go. So from the D1 data, I took ID, visit, and SBP, and then I run that as a visit as 0 visit. I want to rename it as a visit 1, and then I transfer it as a log transformer format. Okay, in order to do that, I think I need to run some package. New ID is not found. Here new ID is not found, they are saying. Okay, now it will run. If I run this, now it is running. Now take a look. Previously it was long format D8. Now it is wide format. Take a look at that one. Are you seeing visit, right? This is the visit. Visit 000. And then visit 111. Then visit 222. Then visit 10. Okay. So 0 visit, the person is this ID, his ID, his age is this. Okay. And then again, after certain period of time, the age will again appear in here. Age will again appear in here. After all of this age will again appear in there. Are you understanding?
They're changing from long to wide.
Why? So are you seeing visit, right? 000, and this is 10, right? Previously all in the long format, now it become wide format. Why we need it? We need it sometimes to compare the performance between visits. For example, now it is easy to compare the pairwise t-test between SBP for the first visit and the last visit.
But respect to DB, it's not wide, is not correct.
Sometimes Sometimes some analysis could be better done by the wide. For example, sample is taken, right? First sample, gene 1, gene 2, gene 3, gene 4. Okay, sample 1 and different people. Okay, then sample 2, different people, gene. And now we want to do the pairwise test. I took a bioinformatics course. In that bioinformatics course, we use the wide format data. So what you have learned, if you have a long format data, okay, let me, if you have a confusions, let me again. This is a long format data. ID, same ID. ID 111, same ID, right? So this is the SBP. Age is different, SBP is different. Now I want to take just only this person. Take, this is the first person, his ID, and then SBP1, SBP2, SBP3. Then age1, age2, age3. Then height 1, height 2, height 3. Or first I like SBP1, age1, height 1, and then weight 1. And then SBP2, age 2, height 2, and weight 2. And SBP3, age 3, height 3, weight 3. Data is this format. Data I want to find wide format. And sometimes data could be given wide format, and then you have to transfer it to the long format. This is what we are going to learn in the next line of code. Okay, again, I return back my data from wide to long format. Now you are saying same ID. ID number same. Okay. 78 is asking you actually if there is a data, complete data. I want to put some missing values, and then I want to impute missing values. These are the things. 78. Just a problem, a little bit high level problem I entered in there. So I'm just running it there. If you do not understand, you can ask me. I can explain those things. What happened? How to impute missing values in a data set. Okay. So do not give a lot of time in there. It is just let me say that this one will work. This is not working. Let me go there again. Now, rest of the code is telling you what? You have a one data in here, another data in here. You want to merge them side by side. Okay. This is merged by side. Another one, you have a data in the top, you have a data in the bottom. How can you merge them by the bottom? Okay. This is called the row binding. This is called the column binding. Column binding means you have a data with 100 rows and you have another data with 300 rows, but you want to put one at the bottom of the another one. So that's the way the 78 and 79 problem is telling you. Come. So merge N1 and N2 data by ID variable, create an N1 data from D1 data by selecting this. So let me go to the D1 data again. I'm running out of time. This is the D1 data. Now let me quickly go there. This is the columns I want to select. After selecting this, and that is the another columns I want to, columns I selected. Then I want to run N1. And then another set of columns I have selected and run N2. Now N1 and N2, I want to merge. Are you familiar with the SQL? SQL? It's very easy, just all together select, right? I know, like Shafali is nodding her hand. So it is just the select. So you have a data set, select this, and that. So this is a kind of SQL left merging, left join, right join, full join, something like this, and union, intersect, something like this. So two data set I have taken. Now I want to merge them. This is the merge data, okay? And there is a one sample I have taken, known as the M1, and then another sample I have taken, known as the M2, and then I want to merge one at the bottom of the other, which is known as the merge data. Okay, that's it. Okay, so I want to take the attendance of you for today's class. Let me write quickly your name, people in the online, and just wait for a second, okay? Write your name and student ID number, please. Write your name and student ID number, and online people, I'm taking your attendance. Just a second. I know Sami Rose. Okay, Sami, you can now leave if you want. Charity, you have to wait because I want to give you new set of problem. Charity.
Okay.
Steve, Shefali. Bartwell and Daddy. Okay, so Shafali, you can leave. Charity and Ololadi, you are taking my 435, right? Or you already took 435?
Yeah, we're taking it right now.
You're taking right now 435. Okay. So I have written down your name. And Charity, you already took?
No, I'm currently taking it.
You're taking currently, right?
Yes.
Yeah. So both of you, I will assign a new homework because this homework you are doing for the 435, okay?
Yeah. Yes.
Yes.
Charity and Ololadi, this homework you are doing for the 435. So the same homework you cannot do for 480. Okay? For the 480 tonight or maybe tomorrow, I will assign a new homework with the handout. It is called clustering or classification with the code as well as homework problem. I will assign. Okay.
Okay. Are we going to get a video for explanation like this?
Hold on. Let me see. How can I increase the volume? Let me see. Yeah. Yeah. Now speak.
I said, are we going to get a video for more explanation like this?
Yeah. Yeah.
Okay.
It could be clustering problem. Okay. See you next week. Have a
Thank you.
week. Bye.
See you.
Bye,
Goodbye.
Rashta. Thank you very much.
Thank you. Bye.